Good afternoon. It's time for Decarbonising Industry, Scotland's answer on this, the second day of Decarbonise Week, our virtual sustainability summit. It's a pre-COP26 event that features stellar lineups on highly topical and relevant panels. I'm Judith Patton, Project Director and co-creator of All Energy and the co-located Dcarbonise. With no in-person All Energy since 2019, we've run a compelling series of webinars, 30 between May 2020 and March of this year. Over 18,000 registered, and the webinars received over 20,000 views, some obviously wanting to have a second look. We're halfway through the All Energy Decarbonise contribution to Decarbonise Week now, and delighted by the number of people who found time to be with us. One housekeeping point, audience, check out what lies behind the resources tab. You can see what is up next, find a full programme link, the digital bag, and information on next May's All Energy. That's 11th and 12th of May for your diaries. Naturally, we'd like to thank our sponsors. And for the first 3 days, these include our brand sponsors, Scottish Power, Shepherd and Wedderburn, and Ørsted, whose names you'll see alongside certain sessions close to their hearts. And our session sponsors, Hitachi ABB Power Grids, Kellis Midstream, SSEN Transmission, SWEP, and Driving the Electric Revolution Industrialisation Centres. And thank you for being with us, today's speakers, and all of you in the audience. If you enjoy the session, let us know, and also let your colleagues know they can watch on demand. Now, without more ado, I'd like to pass over to an old friend, Ronnie Quinn, Chief Executive of NECCUS, to get the show on the road. Over to you, Ronnie.
Judith, thank you very much. And I'll consider it a major win. I've remembered to unmute myself. So thank you. So here we are, Decarbonise Week. We have a wonderful cast of speakers to inform you and advise you of what's going on. I'll introduce those in a moment, but if I can introduce myself first, my name's Ronnie Quinn, and I'm the new Chief Executive of NECCUS. NECCUS is a membership organisation committed to decarbonising industry in Scotland. Why is that important? Well, Scottish industry alone puts out about 11.9 million tonnes of CO2 per annum. That's roughly equivalent to all the cars currently in Scotland. So to achieve these net zero targets, and I'm sure we've heard of these targets before, but just in case you haven't, the UK target is net zero by 2050, and in Scotland by 2045. To achieve these targets, we're going to need to decarbonise industry. We could switch off industry. We could do that. However, that will have a very bad effect on those who work in industry, very bad effect on the economy. So it is not normally seen as a valid option. We have heard the words just transition before, and it depends on how you say it. It could be, look, just transition, or it could be a gentler but firm, fairer way to transition from a carbon-based economy to a net zero economy. I have a lot of sympathy for those who say we shouldn't be in this position and we should be decarbonised already, and we should switch off everything. Unfortunately, for the reasons I've said, that's not seen as a good option because of the unjustness of that approach. The recent spike in gas prices has demonstrated that the market in gas is still alive. We are still a very strong consumer of gas, and until we have transitioned from that reliance, we will need to find ways to make industry work. So, what we're doing at NECCUS is building a roadmap along with some partners, and it's part of the Scottish Net Zero Roadmap project. And what we're doing is mapping where these industrial emitters are and mapping out scenarios for these emitters to reach net zero or as close as they can, so that overall we can reach net zero. That's important. That work is underway and it will carry on for the next 18 months or so. If you would like to learn more about NECCUS, if you'd like to learn more about the roadmap, please get in touch. So you are going to hear a lot more about the Scottish cluster, about the ACORN project, and for that I'm going to hand over to Alan James, who's the Chief Technology Officer at Storegga, who will then pass on to Colin Pritchard, who's the Energy Business Manager at INEOS Grangemouth. Then we'll have Edward Lawns, who's the Head of Strategic Transactions and Upstream at SSE Thermal. And Edward, I know, is having some connection challenges, so we may be listening to Edward on the phone rather than seeing him. We'll then be hearing from Stuart Gregg, who's the UK and Ireland Country Manager at Carbon Engineering. And last, but certainly not least, Stephen Paterson, who's the Chief Financial Officer of Peterhead Port Authority. I'm hoping that we will have an opportunity following these talks to have a discussion. But if you have any questions, please put them in the question box and we'll try and get to them during the course of the session. So enjoy, and I shall pass on now to Alan. Alan.
Ronnie, thank you very much indeed for that. And I think we have a few slides to get the ball rolling. My job today really is to just get the discussion of the Scottish Industrial Cluster started, and then pass on to my colleagues around the room here who are working very hard on different aspects of it. So as you'll see, in the UK at the moment, the theme of industrial decarbonisation is all about pulling together different plant in different industrial centres, and that's what's referred to as a cluster. And this is specifically about the Scottish cluster. You go to next, please. So the Scottish cluster is all about decarbonising industry and moving towards net zero emissions. And the Scottish cluster really needs infrastructure. So it is transport and storage infrastructure for the captured carbon dioxide from industry, to route it offshore and place it deep underground where the carbon came from in the first place. The Scottish cluster is so fortunate in Scotland. We have a massive offshore storage resource which can support this effort. And, you know, we have amongst the organisations you're going to hear from today and others, the potential to step forward and do a lot of heavy lifting to support the UK government and Scottish government targets. As you can see round in the slide there, there's several logos ranging from different parties involved in different industrial sectors, which we'll hear from as we go through. In addition to industrial cluster and industrial capture, we're also going to be moving forward with Europe's first large-scale direct air capture plant. And we'll hear from my colleague Stuart at Carbon Engineering on that a little bit later as well. And also we're talking about hydrogen. Now, the view here is that we're going to need green hydrogen and we're going to need blue hydrogen to get the ball rolling. And the cluster as a whole will be delivering just 1.3, just over a gigawatt of low carbon hydrogen into the energy sector. by 2030. We can go to the next slide, please. So this is a rough timeline. So you can see going from left to right, we start in 2022. Just like putting in infrastructure for housing developments or industrial developments, you need to put the water and sewage systems and the utilities in first. Carbon transport and storage infrastructure is just like that. So we would looking to take an investment decision on the transport and storage activity in 2023, late 2022, early 2023. That will enable its development and construction such that it's ready to receive emissions from all the industrial parties on the call here and others. So we are anticipating the first molecules of carbon to go down the system in 25 and early 26. And then after that, we'll see very rapid deployment of CO2 arrivals from different plant, and including, very importantly, CO2 that will arrive through Peterhead Port. And we'll hear from Stephen a little bit later on this issue particularly. So as those emissions arrive, the system has been designed and capable of being developed and sized such that by 2030, it can be doing around about 10 million tons of CO2 per year and supporting up to 5 gigawatts of hydrogen production capacity. If we can go to the next slide, please. So when we look in detail, this is what the infrastructure looks like. You can see the coast of Scotland there. All the action really centres around St Fergus, which is a really critical hub for the infrastructure itself. Offshore, we're looking to repurpose up to 3 very large gas transmission pipelines. These systems are not used anymore for transporting gas. They are queued for decommissioning. Our plans here are to reuse 2 or even 3 of them to move CO2 from the St Fergus area back offshore and then inject it deep underground, deep under the seabed to 2 to 2.5 kilometers depth. The dark blue polygon there is the offshore storage license that's already in place that Storegga have acquired, and we're working on that with partners including Shell and Harbour Energy. You can see also we'll be bringing CO2 from the industrial area around St Fergus, including our colleagues at SSE with the power plant, and Ed will talk about that a little bit later. We're also going to look at hydrogen manufacture there and direct air capture. CO2 will arrive by ship, as we've said. We also, it's very important to hook up and recognize that the bulk of the emissions from industry that Scotland has sit in the Grangemouth area. And we're working with partners down there, and we'll introduce Colin in a minute from INEOS. And we'll be bringing CO2 again through redeployed gas transmission pipelines from the Grangemouth area up towards St Fergus, so we can get this stuff away and permanently stored underground. So you can see a whole series of different projects which will come together to use and deploy the infrastructure. If we can go to the next slide. So you can see that with having multiple pipelines, a choice of storage sites, and offshore we have 30% of the UK's storage resource within 50 kilometres of that pipeline corridor. So we're in quite a kind of special place. The whole thing becomes an extremely deliverable proposition. And, particularly with the industrial parties that you can see around the room and connected to this initiative, which have a track record of delivering huge projects all around the world. Go to the next slide. Using existing oil and gas infrastructure makes a big difference and can reduce the cost significantly. Broadly, if we had to replace that pipeline infrastructure again and from scratch, it would probably cost towards £750 to £1 billion to do that. And being able to reuse this stuff makes a huge difference. It's also important that we use the full capacity of the infrastructure by having it available as an open system to all of industry to use and decarbonise, so that the project can be scaled up. You can go to the next one. One aspect of the Scottish cluster, as with many clusters, the Scottish cluster is very diverse in its makeup. We have industrial sources, gas processing plants, manufacturing, petroleum refining. We will have hydrogen manufacture. We have thermal power generation and direct air capture. And direct air capture is going to support things like airlines. It will support the financial sector, and somebody somewhere has to decarbonize the towers that are manufactured for wind turbines. So all of these factors come together to produce a very diverse emitter set. And shipping is very important. We anticipate that probably 30 to 40% of the emissions that go through the system will end up arriving by ship, both from around the UK and elsewhere in Europe. And that provides us with a big opportunity for exports later on. We go to the next slide. And as the system builds and more emitters come online, it's very important that the system can be expanded and developed. So having 3 pipelines there that we can bring online as the customer demand develops is really important. And being able to service remote emitters from areas like South Wales, Thames, Teesside, the Solent, as well as Europe, helps other regions around the UK start to decarbonise, who perhaps simply don't have the luck and privilege of a storage resource on their doorstep as we do in Scotland. You can go to the next slide. So there's a lot of work going on just now to bring all this to the fore. The UK government is progressing a procurement process, and we very much hope that Scotland will be as one of the earliest projects and clusters to develop. Ultimately, the UK needs all these industrial clusters to develop, but because we have kind of pipelines in the water, our state of readiness is quite advanced here. And we look forward to supporting other regions of the UK to move forward as quickly as possible. And as Ronnie said, this is a huge opportunity for creation of jobs around the UK and in Scotland in particular. And that is a major feature of this transition. Next slide, please. You can see some of the partners that we're working with on the ACORN project, the kind of consistent and sustained support we've had from governments, whether that's Scottish, UK, or the EU over the years, and our emitter customers and partners around Scotland, together with many, many institutions that have come together to support and back this Scottish cluster effort. Go to the next slide. So now we're going to switch and look at some of the emitter sources and the industrial partners and what they're doing. And to start with, if you can go to the next slide, the area where perhaps some of the first molecules will come from to go down the system will be the gas processing plant up at St Fergus. So this is, it's been operating there for 30 plus years. A third of the UK's gas arrives on shore here and is processed before it's sent to market. That processing of the gas itself creates emissions. And because this is where the CO2 will leave the shore from, we see an opportunity here to capture some of that emissions and compress the CO2 and have that be part of the commissioning volumes that get the infrastructure started. And so we're working with the terminal owners there, including Seagal, which is operated by Shell and Exxon, and the Fuka terminal, which is operated and owned by North Sea Midstream Partners. And these customers, we are working towards building a capture plant there, which will take the flue gas from St Fergus and strip out the CO2 before routing that offshore. What I'd like to do now is pass on to Colin Pritchard from INEOS, and he'll talk a little bit about what INEOS plans are in the Grangemouth area to hook into the infrastructure. Colin.
Good afternoon. Thank you very much. We'll just go to the next slide, please. So Grangemouth, for those not familiar with the site, we have three main activities. We have a refinery, so producing transportation fuels necessary through the way that we live our lives at the moment. We have a petrochemicals complex, which is producing ethylene, which is a fundamental chemical used various industries across the UK. It's piped down further, and you'll find it obviously cropping up in things like polyethylene and ethanol that we also make, but also in things like ethyl acetate that you'll find in for your printing inks. It was going to touch your life in just about every way, as do the rest of the petrochemicals products as they go into biomedical, healthcare, a lot of the decarbonising technologies themselves. We've also got the Forties pipeline system, so the transportation and processing, so bringing crude oil. So a lot of times the liquids associated with the gases that Alan was just mentioning. So in terms of the products, they have an impact upon our everyday life. We employ about 2,000 people directly with, according to Scottish enterprise figures, probably another 14,000 in the wider economy. So there is a play here into the just transition that we need to be part of within here, and we're accepting that we need to take a very active role within that. And we've started at the point when INEOS took over ownership of most of the site back in 2005. And since then, we have already reduced by about 37%, 2 million tonnes. So we've got a countdown from 5 million tonnes. We're, as I say, about the 3 at the moment. And that's been achieved through a mixture of efficiency, optimization, investment, and restructuring. But it's fair to say that we're getting to the stage now where the next stage of going from 3 to 2 to 1 to 0 is getting increasingly difficult. So the next slide, please. So we have made that commitment as a company that we are going to move towards the net zero by 2045 in Scotland and 2050 elsewhere. And this is going to be achieved through continuous improvements in our operational efficiencies. And also we're looking at what we're doing in our feedstock switching. And this will form part of our net zero roadmap that we've announced in the last 2 weeks. But the core part within there at the moment that we can see for our next big step to get from 3 down to 2 million tonnes per year and achieving a 60% reduction overall is by fuel switching, and fuel switching from current hydrocarbon fuels to hydrogen. And blue hydrogen we see as being the route that we have control over on the schedule, on the timescale by which we can deliver this. So that's where we've been announcing that requires an investment of about 1 billion in Grangemouth to actually be able to achieve that switch to blue hydrogen and fuel switching on the site. The other critical part within here, of course, is that the CO2 from that process needs to be captured, and that will be captured and transported up and stored offshore via the Acorn project. And that is, in a simple nutshell, is what we're up to. So we've got ourselves a plan to go from the 3 to 2, and then we will be working beyond there for the next stages, which is some of the build-out options which are available through the capacity that is there from within the Scottish cluster and accessing the geology that Alan was discussing. I'll now pass over to Ed Lawns from SSE, who can discuss what's happening at the Peterhead Power Station. Thank you.
Thank you. Thanks, Colin, and thanks, Ronnie, as well. To follow on from Alan's coverage of the transport and storage system and the broader Acorn cluster, and taking a forward step on from Colin and hearing about Grangemouth feeding into the system, I want to look at Peterhead Carbon Capture Power Station. And before I jump into the Peterhead Carbon Capture Power Station project, it's probably worth just having a quick look back at the history of SSE and Peterhead and why we've ended up where we are today. Now, SSE and Peterhead Power Station have a relationship with the northeast of Scotland, almost amassing to 40 years. And we've been on the Aberdeenshire coast since 1982. And that was when we first opened, it was actually an oil-fired power station before taking forward in the early 2000s a major repowering of the plant to work towards more flexible gas generation. So we have a long history in that area. It is key and critical for us that we support the transition from the carbon-intensive industries to the low-carbon industries that we see before us today. The Peterhead Carbon Capture Power Station project, it is the largest power station of its kind in Scotland. We very much see its role as critical in keeping the lights on and providing the important flexibility to both the grid and also for the backup of renewable generation. And again, for those that know SSE, our interests and development opportunities across the offshore wind space in particular is significant and very much part and parcel of our views and drive towards the low energy transition. So as we look forward to the low carbon future, as you'll have seen on some of the earlier slides here, our partner is actually Equinor in building, developing and operating the new Peterhead Carbon Capture Power Station. They will come with us with the significant background and knowledge around carbon capture technology. And this also allows Peterhead to continue to be flexible in its approach to generation and also consistent with how we see the transition to net zero. So a bit more about what we're hoping to achieve here in terms of the power station. We are planning for 900 megawatts of thermal generation. And from that, we are hoping to capture around 1.5 million tonnes of CO2 every year. And that will replace the older carbon-intensive generation that's currently on the system. And that 1.5 million tonnes of CO2 will connect at a very local level to the system that Alan has talked you through already here this afternoon. Being on the coast, there's a natural fit to the offshore. The proximity to the transportation and storage infrastructure, and adding to the deliverability of how we see this unfolding over the next 5 to 10 years. But we do believe this Peterhead Carbon Capture Power Station could be operational as early as 2026. And that will obviously play a significant role in delivering the UK's 2030 targets. I think, more broadly, the CCS technology in power generation is increasingly readily available. And we think the early projects like Peterhead can go a very long way to stimulating the uptake of carbon capture across the region, and in particular, of course, in Scotland. I think crucially, and I've mentioned already, the transition, if you like, for energy workers and communities, that is increasingly important to us. It would deliver hundreds of millions in low carbon investment and also safeguard the quality of jobs in this industry. And I think from an SSE perspective, already we have around 1/5 of our workforce who have transitioned from high carbon roles into low carbon roles, and we only see that moving in one direction. So I think in essence, that is really the project that we're looking at here. And I think with COP26 around the corner, we obviously feel this is a fantastic opportunity for Scotland and the UK to take not only a role in the power generation space, but also the technology around CCS, as we have already done with offshore wind. And by decarbonising flexible power generation, heavy industry, and other hard-to-reach sectors, we think we can take a major step towards net zero. So thank you for listening, and I will pass you back to Alan, I believe.
That's great. Thank you very much, Ed. If we can go on to the next slide. So we mentioned earlier the key focus of St Fergus, and 35% of the UK's natural gas supply runs through here. Every year, that's responsible for 50 million tonnes of emissions once that gas supply is used. And that not only supplies all of the gas requirements for Scotland, it's also supporting Northern Ireland and a large part of England and even Wales also. And if you think about the infrastructure that we're looking to put in place for carbon transport and storage, you immediately start to think about, well, what if you could take some of that carbon out of the gas that arrives as soon as it reaches the beach and send it offshore and then just provide the market with clean hydrogen. And that's the role of the Acorn Hydrogen Project. So this will be built in a phased manner, ultimately can scale to 900 megawatts or more. And the good thing about being able to work to that scale is that it really helps develop and push the hydrogen economy very quickly, such that when we have enough renewables online to completely support our electricity needs with the balancing required from a plant like the one that Ed has provided, then we can also start to consider using those renewables for manufacturing green hydrogen. And at that point, the market and the sector and the demand will already be there. So that's the role of the Acorn Hydrogen Plant. We're anticipating it starting from 2026 and will be a key part of the way the cluster develops. And at that point, I think I will hand over to Stuart to talk a little bit about direct air capture. Stuart.
Thank you, Alan. That's great. Thank you. Next slide, please. Also, many thanks to All Energy for this opportunity. I really appreciate it. So, excuse me. Carbon Engineering. So we are a Canadian company currently commercializing technology that captures CO2 from the atmosphere, process known as direct air capture, DAC. We have proven that our technology is feasible, affordable, and available as a tool to help us counter climate change. But why is this technology needed? So if you imagine a bathtub holding all the world's greenhouse gases, including CO2, and the tap is open, pouring more and more CO2 into the bathtub, in time, and unfortunately very soon, the bathtub will overflow. Now, reducing our emissions through various methods that I'm sure you're aware of and have been discussed already by the fellow panelists, that slowly closes the tap. But to reduce the water level and reduce the levels of CO2 in the atmosphere, we need to pull out the bathtub's plug to remove the excess levels. And that is exactly what DAC does. That's why this is known as a negative emissions technology. The climate science is very clear. To limit global warming to 1.5 degrees, we must reduce emissions at source. But as the recent IPCC report also states, that we need to remove billions of tons of CO2 from the atmosphere. So we need to remove and also reduce. Over the last decade, we have developed and proven our technology and process by pilot plants. These plants have been built using established supply chains for established industrial equipment from the energy, chemical, and utility sectors. So our TRL path and ability to scale to industrial levels is evident. And we're doing exactly that. We're currently developing commercial industrial scale projects, both in the US and in the UK. Here in the UK, we are working in partnership with Storegga, within the Scottish cluster. This is a really exciting development for carbon engineering, as we are gearing up to start Europe's first commercial viable DAC plant with underground sequestration by 2026, DACs. The project is currently entering the pre-FEED stage of engineering on a 1 megaton plant. That's a plant that's capable of removing the same amount of CO2 per year as 40 million trees. Carbon engineering is highly attractive to the UK, and especially the potential of Scotland regarding the net zero journey. There are clear and unique advantages that could put the UK ahead of the global pack, such as offshore experience, a skilled workforce, proven infrastructure, offshore renewable energy capability, and a superb geological storage capacity, having over a third of Europe's capacity. We believe the UK has all the attributes to become a global leader in DACS technology, a position that in time opens the door to successfully export this know-how. Very similar to what the UK energy industry has done successfully over the last 3 decades. In addition, developing and deploying our DACS technology, as Alan touched on earlier, can also enable the production of sustainable transport fuels, especially for the aviation sector. This approach also assists in stimulating the hydrogen feedstock market. We're also partnering with organisations today who want to take first mover advantages in purchasing credible carbon removal credits linked to the facilities we're developing. As an example, we've already signed a deal with global e-commerce company Shopify, and many more are currently in the pipeline. This further enables businesses to hit their net zero targets sooner and with clear integrity. Furthermore, these transactions directly support our ability to fund our DAC projects, so it's a win-win situation. However, again, as touched on by some of the earlier speakers, for DACs to progress here in the UK, we need to see government leadership, and we need a negative emissions strategy, capital support for early plants, and revenue support to scale the technology. In conclusion, we need to reduce and remove CO2 emissions, otherwise our bathtub will overflow. That means we need to scale DACs now to deliver net zero. Our first DACs projects will be online in the mid-2020s, and businesses can purchase carbon removal credits linked to these plans today. Many thanks for listening. I appreciate your time. And I'll hand over to Steve Paterson of Peterhead Port.
Thank you. Good afternoon, and thanks again for tuning into the session and perhaps more importantly, staying with us until this stage. So I'd just like to say a little bit about our own organisation and then how we intend to progress the exciting opportunity now presenting itself to secure new business through the port. So Peterhead Port Authority is the organisation tasked with holding, managing, maintaining and developing the port at Peterhead. We're a trust port, which means that we're responsible to stakeholders rather than shareholders, and any profits that we make are reinvested into the business for the benefit of future generations. Our main purpose is to provide appropriate port infrastructure and services to enable our stakeholders to increase their economic activity. That requires seeking out and developing opportunities that are sustainable and which add value, and certainly there's no doubt that CCS and hydrogen very much tick these boxes. So Peterhead's been a fishing harbour for more than 400 years, and perhaps it's still best known as one of Europe's largest fishing ports. But we're also an important base for servicing offshore oil and gas operations, with a scale of about 2,500 vessel turnarounds per annum. We have a successful track record in this sector, spanning right back to its genesis more than 50 years ago. But during this time, a significant local marine supply chain and expertise has been established, both locally in the town, in Aberdeen, and also the wider northeast of Scotland region. Many of the skills are transferable, and we see this new industry as an opportunity for some companies to diversify and for employment to be created from an emerging era of clean energy sectors. So why Peterhead? It's about 2 main factors, and the most important one is location, and specifically the proximity of the port to the developments that we've already heard about at St Fergus and at Peterhead Power Station. Much of the infrastructure that will be required in connection with these developments will also be shared with an import and export terminal servicing shipping through the port. This will allow bulk tankers to deliver or export CO2. Secondly, we're fortunate to already have the main attributes required, a deep water port and an infrastructure that's already in place. A jetty, which you can see on the slide there, was originally constructed in the late 70s, early 80s to facilitate fuel oil imports to the power station. It was designed for tankers up to 200 metres in length, delivering up to 40,000 tonnes of fuel at a time. The trade started off on a very regular basis in the early 80s, but slowly declined as the station transitioned from generating electricity from oil to gas, and the final ship left in 2006. The jetty can be readily adapted for large-scale CO2 imports, involving what we hope will build up from an early start in 2026 through to millions of tonnes per annum. Repurposing this jetty allows the project to be operational up to 3 years earlier than if starting with a new build, and saves up to 40 million in upfront costs. It's maybe not as much as the pipelines that Alan was talking about earlier, but it still makes a difference. The technical studies, engineering considerations, marine planning, and various other studies required for this new operation are now underway. But unusually for a harbour project, because shipping of large volumes of CO2 is an entirely new concept, even the optimum size and design of the vessels at this stage is still a work in progress. Should the trade grow to exceed the capacity of the berth, well, there were plans right from when the jetty was first built to provide a second discharge point, and these are now also being dusted off and refreshed, just in case the volumes of CO2 increase beyond that, or potentially for facilitating hydrogen shipments in the future. So many, as we've heard already, many areas of the UK and Europe have a need to capture CO2, but without anywhere locally to store it. An import facility at Peterhead helps them to meet their net zero obligations, whilst at the same time providing a significant new business opportunity for this area. Such opportunities only come around once every few generations, so have to be welcomed and nurtured, and we'll certainly do whatever we can to help this along. So I'd like to hand back to Ronnie Quinn for a question and answer session.
Thank you very much, Stuart, and indeed to all the panel for giving us that overview. From the questions that have come in, I'm pleased to say that many of them have already been addressed in the talks that you've already given. But given that, Stuart, you have just finished, I'm wondering if I could come back into you, because there's a query as to how realistic it is for Peterhead and indeed Scotland to take in CO2 from the rest of the UK and indeed Europe. Is that possible?
From a DAC plant is pretty agnostic where it's actually placed, as long as we've got the geological structure and the ability to transport it from a DAC's perspective, but other aspects of DACs, such as fuels, it's pretty agnostic. I think what's key for Scotland, for us in any way, is the amount of renewable energy that is available now and the amount of renewable energy that's planned for the future. So currently we are looking to, working with Storegga, have a plant that relies reliably on green energy predominantly. But what really boils down to for us to be successful is the government to really look at what DACs can do for the net zero targets. I'll quickly go into that. So if you look at that IPCC report, if you look at all the different carbon pathways that the UK needs to take to net zero, you're still left with a gap of around 40 to 90 megatons of emissions that need to be abated. And that's predominantly from the agriculture, aviation and marine industry. And that's where DACs plays a huge part. However, what the government also needs to recognise, and the conversations I'm having with government as well, that we are definitely getting sort of feelings that they do recognise the opportunity DACs brings, is that we need incentives. It is a first-of-a-kind plant in Europe that's commercial scale. So first-of-a-kind plant needs regulatory backing, it needs policy backing, and it also needs to allow the finance community to have the level of reassurance that allows us to put this plant into play.
Thank you. Alan, there's an interesting query here, and it is probably very optimistic in its view. If we start injecting into the acorn field at the rate of 10 million tonnes per year or more, when is it likely to be full, and what happens then?
That is a great question. So the pipeline corridor that we pointed out earlier there are some 23 gigatons of storage resource in that corridor. The Acorn storage site at the moment, we have an ambition to place around about 150 million tons in that license, but we're also pursuing additional areas which would provide gigaton scale storage, so that the storage resource is not the pinch point, if you like. That is there in spades. The key thing is to make sure it's ready when industry needs to use it.
Thanks, Alan. I noticed this morning, and it's referenced in some of the questions, that there were some comments by the Prime Minister this morning which seemed to be positive in, and I'll say no more than that, in his assessment of the Scottish cluster bid. Do any of the panel members have anything to say about that?
It was nice to see him acknowledge the strong offering that we have from Scotland. I think we have to wait for due process.
Yeah, I echo Alan that. Again, as I said earlier, the conversations I've had at political levels echo what Boris Johnson and Alan have just said. I think I'm super excited for the later in October when it's announced.
Thank you. Stephen, will the PPA needed to amend existing harbour regulations to accept the movements of CO2 shipping, and would the expected volume levels require new maritime regulations, particularly regarding health and safety?
There are a whole range of different studies being commissioned at the moment, looking at specifically the marine traffic and the impacts on the port and the health and safety regulation. I think CO2 shipments are probably less problematic than hydrogen, but both have been done in other ports in similar circumstances to ourselves. So we don't foresee it being an issue, but it's certainly something that's on the radar already.
Thank you. And now, one, it's not mentioning it specifically, but I suspect it's alluding to it. There was a report published earlier on in the summer, an American report, saying that the production of blue hydrogen was not net zero and didn't contribute and was in fact harmful. And given that this is a key part of the cluster bid, I'm wondering if anyone would like to say anything about that study, bearing in mind I'm aware that that was a study based in America, and there may be issues about converting that into a European context. Could I start with you, Alan?
Yeah, so I'm familiar with that, and I've read it through. I mean, the key there, Ronnie, as you said, it's an American study, and the life cycle emissions of natural gas in North America are extremely high. They're way higher than they should be, and in the North Sea, our life cycle emissions for natural gas from the North Sea are extremely low, amongst the lowest in the world, and that makes a massive difference. So, there's data published by several parties here in the UK, including the Oil and Gas Authority, and that's the place to look to take the benchmark. So, of course, there are upstream emissions, but this is part of the role. This is why we've designed the DAC project into the program so early, because we can look to remove any fugitive emissions through DAC technology, and remember, it's about net zero, not completely zero. It's net zero. So where we do have fugitive emissions, as long as we have negative emissions technology to compensate for that, we can retain net zero, and that's very key.
Thanks, Alan. If I can, Ed, if you're still on the line, come to you first. There's a query as to whether or not any of this is actually real and whether or not any of it will be built. If I could go to Ed first and then perhaps again back to Alan. But Ed, if you could come in on that, Is the CCS-enabled plant at Peterhead real?
Yeah, but listen, thanks, Ronnie. And listen, it's a great question, because as the audience will know and the panel will know, we've been here before, and we've been involved with CCS for some time. Previously at Peterhead and obviously up in Scotland, and we've also been involved at Ferrybridge in West Yorkshire, and they didn't quite come to fruition. However, what I think is different this time is the net zero target that Alan's just mentioned there, and everything has really changed. The government policy, I think the technological advancement and the appetite from industry, as you're seeing here today in the panel, it's all aligning. And I think now is the right time for us, and SC, we strongly believe that CCS is here to play a significant role for the UK going forward. I think in addition, we know that existing gas, nuclear, coal stations are closing and being phased out over the next 5 years. And I think there's a real seriousness to net zero. And it's also crucial that we replace generation from low carbon. So, yeah, I think this time round it feels real. I think there's a huge commitment from across the political landscape, but industry as well. So,
and Colin, I'm assuming you could echo that as well.
Yeah, indeed. So the thing at the moment is, I think there was another question actually that was in relation to the what stage are we at, and rather than name what stage we're at, I would say that the biggest thing to remember with all of this is that the engineering and technology exists. We know how to capture carbon out of gas streams. It's something that the industry's been doing for decades. We know how to ship it around. We know how to put it down pipelines. We know how to store it under the ground. So CCS and the other technologies we've been discussing are less a technological challenge than they are a commercial and I guess even a social challenge about the acceptability of them. And that's probably the thing that in the last 12 to 18 months has been the most significant sea change, certainly that I've seen. The way that governments are talking about CCS projects now is less about we should do them and they should happen, and it's more about, well, what does it need to make it happen? How do we need to structure business models to support these things so that they will work? So I think in terms of a question of are they real, is there something you can physically touch today? No, but we know how to build it. And the biggest thing that's changed is the political landscape. That means that there is a will that is supporting the know-how that the industry, that hopefully you've heard in today's webinar, that it exists. The biggest thing is that political will has come to support that. So I really believe it will become real, and you will be able to touch it in a remarkably short timescale.
Thanks. And Alan, in the presentation, there was a timeline slide there, and I suppose underlining that is the assumption that it will happen then. How, does that timeline still hold true, and will we be able to look, and as Colin suggests, be able to touch something in the middle of this decade?
I believe that's absolutely right. I mean, much depends upon government decision making about which clusters the government chooses to move forward first. But if we're fortunate enough to be one of the early clusters, then we will be tasked by government to be deliverable and operating by the mid-2020s. That'll be our job.
Thank you. Stuart, back to you. And again, it's coming back to this question of, does DAC work and is it efficient? And in particular, how much energy is required to run a DAC plant? Does it add up?
Yeah, so before I go on to that, I'll just add to the last point. I think the big difference this time is the government's net zero targets are enshrined in law. And because they're enshrined in law, the previous incarnations that we had, such as the Peterhead Power Station CCUS project that was cancelled, the government can't be in that position anymore. It needs to act. So I think what you're seeing, the conversations I have at a governmental level, is they are really keen to look at all tools that can help them on the net zero journey, DAC being one of them. So the question that I just received there is a question I receive a lot. And I'll build on what Colin actually said. So the technology we use, other than the intelligent property that's involved, is classic technology from process industries. So oil and gas, utilities, chemicals, agriculture. So our ability to scale is obvious. We start off with a very small pilot plant that was 1,000 tons per year. We proved it at that level. Then we moved to 3,000 tons per year, and the same technology scaled up, and it worked exactly the same. And now we're moving to megatons. So that's a big jump, but that jump is based on the experience of the team from other sectors, of what they've done in other sectors, and also what's been proven in other industries as well, and the ability to go from volumes that are low, using the same equipment on a larger scale, to volumes that are high. Is it affordable? Yes, it is affordable. So we currently work around the remit of around 100 tons of CO2 per ton, where we expect to drive that down as we go through the innovation curve. We're already seeing that within our innovation center, our ability to drive down that cost. And working with Storegga, when we design the plant, construct the plant, and we go specifically when we go into operation, we'll take every single opportunity, as the oil and gas industry has, to get to the place where the plants, as they go through the next generations, have the ability to sequester more and more CO2, but at the same time, the price, because of efficiency, starts to come down. And that's the price in both the build and price and the OpEx side of the curve as well.
Thank you very much for that. I'm just conscious of time and the need to close up. So are there any other points that any members of the panel want to raise that they haven't had the opportunity? Ed, I know it's been difficult for you on the phone. Is there anything else you'd want to add?
I don't think so. I think there's huge support, certainly on the panel, as you've heard today, and commitment to make this happen across the wider industry. So I think an exciting time ahead. So thank you, Ronnie.
Thank you. Alan, just to close off, in respect of the Scottish cluster, could I just ask, when are we expecting to hear from the government about the cluster sequencing bid, and how soon are we ready to move thereafter?
The official line is that we're expecting to hear and be notified in the week of the 25th of October. And as far as moving forwards, I think you'll find that there are many players around the room that are already moving forwards in anticipation of a positive outcome, to the extent that they can, until it's fully confirmed. So the momentum is there and needs to be preserved.
Thank you. And how positive? I mean, Ed was confident there that industry is in a good place, and it was a sentiment also echoed by Colin, that things are different this time and that it will go ahead. If I could give you the last word here, Alan, how comfortable are you that we're going to make it this time?
We'll make it this time because we have to. We got no choice as society. We need this technology to meet our net zero targets and to lead the world and transfer this stuff around so that we can get a grip on the climate change issue.
I don't think there's a better way of closing today's seminar than that. This is something we need to happen. We need it to happen at scale and at pace. And I think we've heard from the panel today that we are on the cusp of making this happen at scale and at pace. So it just remains for me to thank Judith and the team at All Energy, and indeed all the panelists with us today. Thank you very much for your time, and indeed thank you to you for your questions. Thank you for listening in, and watch this space. Thank you very much.
Thanks, Ronnie.